Good day. Welcome everybody. This is our part one on our Studio OP webinar series. My name is Bruno and I will take you through the new dynamic pit design functionality. I will share with you some basic principles of the tool and how to operate it on a practitioner point of view. Myself, I've been using the tool for the past 3 months or so and applied on a few projects already. And I gained some idea of how to get the best out of the tool for now. And I want to just share with you the way I'm using it and perhaps the way you can start using yourself. I'm not approaching this at all as a training session. Really, my main goal is to share with you what's possible to be done and obviously how to go about it on a nutshell. The session is really short. It's only between 35 to 40 minutes, and there's a ton of information that I want to share with all of you. And said that, I'll suggest for us to keep the questions to the end if we do have time. There's more than 100 people on the line, so if I open up for everybody, we're going to be here until tomorrow. So, but I also encourage you to share your questions and send the questions to you to us using the sales at dataminesoftware.com, where we can perhaps compile all the questions that came and put together a little FAQ and circulate among everybody. All right. So without further delay, let's get cracking. Let me just take you now to my Studio P environment here. So I'm sure that most of you should be familiar with the interface already, with the ribbons interface. For today, I'm going to be focusing pretty much on the setup and on the design only. All right. On the setup, I'm going to take you through some of those menus here, where we need to define a few little settings before we can start using our dynamic pit design. And on the design, I will focus only on the 4 items here under the pit modeling. All right. All the rest here is the well-known tools that you guys have been using for the past years on the normal pit design methodologies. So I'll take you through some setups and designs, and hopefully you can exercise this on 2 data sets that I have prepared. But also I would like you to start with me on a very basic situation, just for you to understand how the tool works, more like a experimental first run here together. All right. So to do that, let's go to setup, and on the setup, I'm just gonna start with the manage. Notice that I have this task control bar here. That's a very important part of the deal. Is going to be, that's where your interface is in the end of the day. You're going to be interacting with those items here via this control bar. So your task control bar is quite important on the dynamic pit design. You can dock it on your second screen if you do have. I don't have the luxury here on our webinar, so I'm just going to keep it here on the side for me. On this very first stage here on the manage, I just need to define a name for my pit, you know. So this one is pit 1, but I'll say pit 0. It's going to be the first one. I'm just going to save, and I'll move forward straight to benches. I'll skip those ones for now, just to show you how quick you can go to the design without really spending too much time on the setup. So just define a name, go straight to your benches. And on the benches, that's a very important part. You need to define what is the reference level for your benches and also what's the bench height that you're dealing with. On this case, it's going to be just an experimental thing, and I'm going to say that I'm on the crest elevation maximum of 100, and I'm going to have bench heights of 10 meters and a collection of 10 benches only. So I'll say apply. And this system would automatically populate for me the table here with the bench heights, crest, mid, and toe reference levels, and a labeling here. Obviously that you can define variable bench heights, maybe saying this first one is going to be 8, the second one is going to be 12, and so on, and the reference levels are automatically recalculated down. But the intention here is not that is just really to show you that it's possible. Right now I just want you to bear with me here on a very simple bench height situation. So I've done the manage, create a pit called pit 0, went to define and create some benches for us. Say save, then I'm ready to go to design. On the design, I'm going to focus initially on the define slopes. Right, here's where we're going to instruct the Studio P how to go about on the angles and configurations of the berms for our pits. right? So the pit wall is going to be controlled by a face angle, berm width, and eventually some catchment berms as well. On a manual mode, I'm just going to simply, I also have the planning and the planning model and boundary strings, which I'll take you through slightly later. I just focus on the manual first. I'm just going to create a very simple situation here with a 45 degree, or let's say 40 degree face angle, 10 for my bench, sorry, to my berm width, and 20 for my catchment. Okay, I say save. So just very simple geotechnical setup. I can go to my auto design, and in here, this dialog box here, you can interact with new roads, perhaps introduce new roads, edit those roads, and also create some pit constraints, which is on the core of this new functionality. You must define now a base for our pit, right? So I'm just new string there and create a base, and I'm just smoothing this a little bit. So this is going to be the very first string on my bench, sorry, on my pit. I just noticed that I used the wrong elevation. Let me just get myself on the right elevation. I'll just translate this string, so TRA to -100. I'm sorry for that. But the cool thing is that all the functionalities that you used to are also available here, and you can freely interact with your object strings like you've been doing before on any other 3D window, VR window, design window. So it's pretty much the same. So here now I'm on the right Z elevation there. Let me just get my view right, and now I'm comfortable to go. Yeah, cool. So I can just say recalculate, bingo. The walls are created following the bench heights that I've defined, and also the slope consideration that we defined. So you can see a very gentle slope angle has been applied here. If I simply go back to my design and say my defined slopes, actually the face angle is not 40, is actually 60. You can see automatically the effect as I go back here into the auto design and recalculate, that's already applying a dynamic change for me here, right? So that's the nature of the dynamic pit. Is going to be a very interactive and dynamic interaction between you and your pit design, and then you can start creating some extra addendums on those pit and extra strings to control the way this pit is gonna grow. So for example, if I am on a, let's say, one of the cool things here that I can use this bench, so I can go to bench 10, to the toe of the bench 10 and clip myself there. So I'm gonna clip myself there, and I can move bench by bench. So let's say on this specific bench here, I have a set of blocks that I need to bring into my pit, and I can say new string here, snap, and just digitize this extra piece here, snap again. Just bear in mind that this must be a closed string, so I'm going to CLO to close it, right? And now this feature is going to be part of my design. I just need to press the recalculate button, right? So automatically recalculates for me the shape of the walls, and I can do the same thing going a little bit further again, maybe, and then clipping again and introducing a new one this side. Obviously, I'm not following any pit design here. I just want you to understand how this functionality works. So the pit constraints are very important entities here, and they will help you to shape up your pit on the way you want. They must be closed strings, and they will be guiding you to get the walls on the right position for you to follow your pit optimization, which is ultimately the goal for us when doing the pit design. But this is a very simplistic approach, right? Like with very little angles, variations, and constraints, and so on. So, but that was just to give you guys an indication of how the dynamic inside of the pit design functionality works. So let's go back to the defined slopes and think about a situation that's slightly different with a little bit more variability. Let's say that you want to use a boundary string. The boundary strings allow you to perhaps bring your a set of perimeters that have a different geotechnical zone, right? And your pit should obey to those different geotechnical zones within those given perimeters. So on this example here, I'm using this boundary string that I have prepared before. If I just show to you on the screen how it looks like, there you go. So I have a zone 1, zone 2, and zone 3, and the field, the geotech here, holds the different attributes there. So when I define this there's a string as a boundary string here on the process, and I identify the field geotech as my region ID, automatically the system populates here the options for me. So I have obviously the default and region 1, 2, and 3. So on this example, I'm going to say the region 1 is going to be a 40-degree phase angle on a berm width of maybe 10 and on a catchment of 20 perhaps. And then on region 2 is 60 with a 10, sorry, let's say 8, and then I get to a 12. And finally, region 3 is going to be a very aggressive one with 80, and then 4 and 8. All right. So let's see how this thing changes the way we see the pit designing them. So I'm going to go to the auto design again. My original scribble sketch is still there. Let me just locate myself here. If I just bring again the slope regions, oh, there you go. So I'll create brand new pit constraints for me. So I'm just going to get rid of those ones for now. And then let's perhaps create 3 little perimeters there. So just smoothing this guy, and I just simply copy this across there. Oh, no, CPS, yes. There you go. CPS, this here. All right, so I just copy it across and just move this guy slightly this side. Okay, cool. So now they are my new perimeters. I notice again that I'm on the 70 elevation. I'm doing that thing again. Let me just move myself to 0. So TRA minus 70. Okay, there you go. So those guys on the right place. This is a duplication right there. Cool. Those guys are on 0. When I press recalculate, there you go. I can clearly see that on the zone 1, there's a much more laid back slope there, here, average, and this one a very aggressive slope as per my definition. If I simply start moving those guys closer to each other, I will start seeing the way they interact with each other. So I say recalculate, there you go. So you can see that clearly they start merging into each other. That's why I have this conditioning here that we call the blending distance. Right now my blending distance is 200 meters. If I drop it to 20, the way that this change takes place is much more abrupt. So you can see that the changes are maybe not ideal. Obviously this will depend on the data set I use, in the size of the benches and so on. For me, most of the time this conditioning at 100 meters of blending works just fine. All right, so this is just how the angles are being configured and being used, and how those different perimeters are getting together. If I just get rid of those guys and do one single one, just to give a little bit of example how the roads look like before we get into a real data set here. Just say this is my perimeter now, and I'll say SMS, for example. Okay, so if I decide now to introduce or to recalculate this, so recalculate, there you go. That's how my pit looks like. You can see a very aggressive, medium, and very gentle slopes there. And then you can now start playing around with a road. So just a new road, say road 1, gradient perhaps 10%, 15 width, for example. I just need to start this road somewhere, perhaps there. So you can see that the roads are automatically created for me and merged into the walls, following the same considerations, geotechnical considerations based on the perimeters. I can now edit this road a little bit, maybe move the starting point from this point to that point, or perhaps even to a different elevation if I will. I can introduce a switchback on a given elevation. So let's say I want the switchback to happen on this elevation there, so I can snap on the elevation, and the switchback takes place on the elevation that I have snapped. All right. You can obviously still move the starting position of a ramp, and the switchback remains on that specific elevation that you defined. And you can define also the end elevation of the road to stop on a given contour, if you will. Okay. So this gives you, on a nutshell, an idea of what the tools that we have put together can do, and then I'll try to now show some application of those tools on a real pit data set. If I just go back to my defined slopes, There is also the planning model option, which is my preferred, I think gives me more control. The planning model allows you to use a block model that contains some sort of geotechnical attribute that tells you what is the conditions of the walls on that specific area. And that allows you to do a very complex and comprehensive setup of your geotech. And for me, it's my preferred option most of the times when I'm dealing with variable face angles, all right? And that's the one I will show you guys briefly here. My data set looks like something like this. If I just look on the screen, is a very simple data set with only 2 geotechnical zones, one a little bit more competent, other one a little bit less so. If I just put on the screen here for us to visualize it, so my geotech, bear with me here, and blocks, okay, cool. There you go. So that situation, the blue zone is going to be a little bit more less aggressive in terms of slope angles, and the red one is going to be a little bit more steep. So if I just perhaps put a section across here for us, let's say northwest, let's see where I am here, not far out. There you go, here I am. So if I slice this thing, there you go, so you can see that there's some variation there on the contact between the fresh and the soft area, or the hard and the less competent rock. So I'm going to use that type of information on the block model to guide my pit walls on this exercise. Okay, just unload all here. So that's the data set I'm going to be using. So then, setup, I'm going to start a new pit. So I just take this view out, this indicator. Okay, so setup, manage, I'm going to say new pit. Let me call this guy pit A. There you go. Save. On this case, I'm going to define a surface. It's cool to define a surface because then I can interactively use the surface on my design and see where the pit is reaching the topo or going through the topo. So it's quite handy to bring a topo into the perspective. I just need to bring the file and assign the file to the given pit. So it's a pit topo. There you go. So I'm assigning this file to the pit A. Save. Then I'm going to do the same. I'm going to bring a model, not just any model. It's going to be optimized model. I've used NPV Scheduler to produce an optimization for me, and I'm using those results, those blocks, as a guide for my design. At the end of the day, I want to make sure that my design aligns with the my strategic decision and my optimized block. So it's important for us to bring a block model for the design. As I showed before, you don't it's not a must, but I think you should. So in here, I need to make sure that I pick up the field geotech and assign it specifically as slope regions, because I want to use it as slope regions. Remember, the field geotech was the blue and the red blocks there on my screen, and I want to make sure that I can use them as slope regions. So I'm doing that here, and obviously I need to assign the block model file to the corresponding pit, which is pit A. Save. Then I can go to benches. I will quickly generate benches for me. On my drop now I have 2 benches now, sorry, 2 pits, pit A, and I'll quickly generate benches by just simply scanning the planning model that I have defined. So pit A full mod is going to be scanned, and then it will create automatically for me the reference levels, toes, mid and crest reference levels, as well as the bench height automatically read from the block model. All right. I'll say save in here. I'm ready to do some designs. First thing I want to do is go to my slopes. In here, I need to pick my pit A because now I have 2 pits on this situation, and I want to use a planning model. That's what I'm going to be busy with. So I'll say planning model, and automatically picks up the geotechnical region defined on my pit full mod. In here, I'm just going to create the correct configuration here, which is for my zone 10, which is the blue zone on the top, is 60 meters for face, 6 degrees for face angle, 5 meters for berm width, 10 for my catchment. And on the zone 20 is going to be 85 for my face angle, 4 for the berm width, and 8 for the catchment. And in here, I'm going to just make the default equal to the zone one, which is going to be 60. So anything that's outside of the block model is going to be taken as such. All right. One thing that I haven't mentioned on our previous example, on our experimental example, is that you can control the bench in terms of catchment and berm width. So I just want to show you quickly how to do that. You can come to the bench constraints here, and you can define on a given elevation if you want a standard berm or a catchment berm, right? Let's say that for this example, I want to do for every 4 benches, I want to set my berm type to be a catch. So from the top down, it's going to create several catch berms every 4 benches for me, right? So what's going to happen, and when the design gets to that specific level, is going to be ruled by the berm width on the catchment side and not on the standard side, right? So we're going to see the effect of this on our design shortly. Okay, save. Now we're going to go to shell contours. On shell contours, something that I have skipped before, but now I can show you, is where I'm going to define a wireframe wrap around my blocks, my optimized blocks. That will assist me and guide me to get my design as tight and close as possible to my optimized blocks, which is ultimately my goal when I'm doing my pit designs. So just need to pick pit A. So pit A has a planning model. We defined the planning model, and therefore I can use the planning model to create those surfaces around specific pit shells. On the list here is all the Latch-Grossman pit shells that I've generated inside of NPV schedule. I can pick anyone on the list, right? If I pick, for example, this one here, and quickly generate for us a output here, it generates a wrap of triangles around a collection of blocks, right? So it looks like something like that. I want to go full on. I'm going to go and take the last pit, my full pit, and generate a wireframe wrap for me there. There you go. So this is contouring, creating those nice wireframes around my block model. Each, for illustration, looks like this. There you go. So you can see that the wireframe is being created to wrap around those Latch-Grossman phases blocks there. Okay, cool. So back to my task. Now that I have this wireframe, we can create some contours, right? And see on a bench by bench or on a fixed elevation. I'm just going to go on the benches that I have predefined. So it's going from 10 in 10 increments, and you can use some splines as well to give a little bit of more smoothness on the creation of those strings. Those strings I can then use as constraints for my pit design further down the line on the auto design. So that's why we're doing this specific step. And the cool thing is that those strings are intrinsically connected to the optimization blocks, right? And again, that's ultimately what I want to get. Cool. So that's generate some contour shells. Let's save this. On the ramp layout is where I can start playing around a little bit with the possibilities for my ramps. Not designing the ramp per se, but just having an indication of how the roads would lay themselves out in this hypothetical wall that I've just created here. So on a 10% gradient here, if I say start a ramp somewhere in there, that's how the ramp would go about on the pit wall. I can obviously play around with the starting position of this ramp, right, and see where the ramp would, how the ramp would change if I change the starting position of it. I can add perhaps a switchback and a given elevation, let's say there, for example. Okay, and if I want, I could perhaps add another road there, road 2, I don't know, and also clockwise. Maybe it's counterclockwise, this one here, or clockwise, but going from this point there up. There you go. So something like that. That just gives me an indication of how a potential road would look like and where it would be eventually summiting, right? Obviously, as I start getting those roads into the constraints that we have defined, things go a little bit different, and you always need to do some fine adjustment. But this is just a rough indication of how those roads could be laid out. All right. I'll say save. Now I'm ready to go to my auto design. me just double check something here. Yeah, on my stops, everything looks good. Okay, so on the auto design, now I can use the perimeters that I've created on the contour shells to be my guidance for which perimeters could be my control strings. Huh? So I'm picking a few of them here, perhaps 3 of them, right? I can even pick up this one, perhaps this one as well. So I'm going to add them as part of my constraint strings, which currently I have none, but like I'm just going to add them to it. And then if I now turn off my contour shells, so my contour perimeters, I can see that those guys have been defined as constraints, right? Now they have been defined as constraints, I can just say recalculate, and there you go. It's shaping up for me the pit quite nicely, right? It's already reading some of that information from my roads as I have defined initially on the ramp layout, right? So it's already picking up some of that instruction and combining with the constraints and already laying out the road positions here. This thing here is a little bit wavy and I don't like this type of shape, so we can always fix that. So what I'll do, I'll hide this design for now and I'll start doing some conditioning on those strings. ICS is a quite handy tool for those things. If you haven't used ICS, insert curved string. So I'm just going to smooth it a little bit more straight. So if I see my recalculation here, that's how my road looks like. Now my road 2 seems to be a little bit too close to my road 1, so I'm just going to move this road 2 start point a little bit to that side. There you go, something like that. Okay, I'm happy there. And perhaps I'm going to make this road 1 a little bit wider from this point onward. So let's say I want to change the road 1 width, so I can experiment by changing the width to 20, let's say, and I'll pick from this elevation all the way to the top. There you go. So this road width has been just increased by 10 meters from a specific point and up, right? Why not do the same with road 2? Road 2, I want to also increase the road 2. So say I'm gonna AQ from here to here at 20 meter. Okay. Funny thing that is sometimes it happens. Generally, sometimes I generally clean these issues here on my above bench, and then afterwards I can just once I have my project done and dust, I can just delete those guys and condition this road entrances a little bit more at the end. One thing that those roads are not going all the way through. So let's just get the I can say that my road 1, for example, I want to go all the way to the top. So I'm going to move my end elevation for road 1 all the way to the topmost contour. So road 1 is going to continue until it goes all the way to the top. However, I don't know as the topography here, because I haven't turned on a pretty cool tool here that can mark for me the design strings above the topo. So if I mark this thing on, there's a little bit more processing time more involved because it's trimming with the topo, but you can see the benefit of it. I can see that now everything that's on dashed lines is because it's sitting above my topo line. So my road 1 actually doesn't need to go anywhere further than this elevation because I'm already summiting here on the topo. So I'll just say end elevation of road 1 to be somewhere in there. There you go. Cool. And road 2 seems to be summiting already as well. Maybe road 2, I'm just going to give one extra bench for it. And elevation for road 2 to be there. And you can clearly see as well that the catchment berms were introduced every few benches, as you can see there, as we have defined on our slope definitions. If you want to see this design against the topo, there you go. You can see that's why it's important for you to bring your topo together on the project, and you can see how your pit design looks like trimmed to the topo, and if the roads and so on, walls, berms and catchment berms introduced. Look, I think on a nutshell, that's more or less what I'd like to share on this specific scenario here. It's a small pit, but it's easy and very quick for us to relate and see some of the functionalities. We have some time here, and I want to show you a second data set, which is much larger, a pit with like probably 35 plus benches and 600 meters deep. So it's a much more complex data set, but we can, as easy as this one, handle the same amount of complexity. So I will just save this thing here, and I'll take this as an opportunity as well to recap the way we defined all the steps of the setup of the pits and of the slope angles. So remember what I said, we started on setup, we can manage some pits. On this case, I'm going to create a brand new pit B, right? We save that, we define a topo, we can add a topography here, pit B topo, and I can just pick on the list and assign pit B to the correct topo file, save. I'll do the same again, I'll bring a new block model now, but for pit B, which also has been optimized, and I'll bring it in here and assign it to the pit B. So the NPV mod pit B is going to be assigned to pit B, save, and again I'm going to benches. In here I'll pick my pit B and I'll create my benches from the planning model. I think it goes way deeper than I actually need, so I'll just revert back. Let me just clear all those benches, yes. I'll revert back to a manual. I'm going to start with 1510, and I need 20-meter bench heights, and I need probably, I think it's 60 benches on this example here. That should be enough to cover the spectrum that I need. So create a pit name, bring a topography, bring your block model optimization file, define your bench heights and reference levels, right? You're good to go. You save this, go to your design, define slopes. In here, I'm going to pick my pit B now. That's my area of interest now. And this is going to be, I'm just going to put a fixed face angle for this one here. Fixed face angle all around, and a berm width of 5 and a catchment of 10. So very simple approach here. And bench constraints, I'm going to make, again, for every 4 benches, set one of them as a berm catchment. So same, so it does this across the benches. Save. I will do some shell contouring here. Just pick the pit B. So I'll do the shell contouring of pit B. And on pit B, I also have some options there. I have some different collection of blocks. I'm going to take the biggest one, which is the 9, and I'm going to just generate from model wireframe wrap. There you go. So this is a quite large data set. It's if I measure here, this is over 5 kilometers. So the time as limited as it is, I'm just going to show a bit of the design on this specific zone here. Okay, I'm happy with the wireframe. I'm just going to create some contours to help me to guide my pit constraints. So I'll say save, and I will skip over the ramp layout. Not really interested right now. I just want to go straight into the auto design. And in here, I'll just start picking some of those perimeters that attracts me. I think this one here, obviously, is one of them. This one as well. And I see just follows the same trend and eventually opens up a little bit. So maybe I'll pick up this one there and this one, both. And on this side, I have a new bottom, that side opening up. And then it's just following some sort of trend. Perhaps pick this one and this one there as well, and this one. Just picking some blocks there, some options there. Perhaps this one. I think this is just a continuity of this one anyway. So I think I'm happy with this. Note that some of them are open. It's not a problem. Just say CLO, close those perimeters. Is not an issue. Okay. It does look a bit funny at the beginning when you have something flying over your pit, but don't worry. That's the way it is. It's not going to be a problem for you. So you just close it, and now we are happy to define those guys as a pit constraint, right? Right now my pit constraints are empty, so I'm going to say add them. Now my pit constraints are the ones that I've just have defined. Let's unmark those guys for now. Let's see how the recalculation goes. There you go. All right, so that's just using those projections to create my my first frame here, if I quickly bring the pit optimization, sorry, the optimized pit, that's what we're looking at. I just bring this guy as blocks. Okay, there you go. So that's what we're looking at. So it already has a very good fit into our design on a very quick way. Obviously, there's a lot of adjustments to be done here and there, but I think just on a quick basis, that's how quick you can get to this point in time here. Some of those wavy shapes don't really make me happy, but I'll leave it there for now. So we can then perhaps play around a little bit more. We have some time just to create a few roads here to see how they would go. So I'll create a new road here, say road 1. This is a 10%, there's a quite wide road, so let's say 30. And I'll start somewhere in there with this road. Let's see what happens if I do that. It's a bit locked. Let's just move the end, the moving start point of this road to be somewhere. There you go. So all the way up. And then if I perhaps create a similar road on the other side, but now on a counterclock, and say road 2, and then pinning in there. There you go. So the road goes, so they eventually cross each other, but doesn't really matter. If I look at the topography, so let's trim those designs to the topo. Let's see where do they summit. There you go. Okay, so road 2 is getting on one side, road 1 is getting out on the other one. Shapes like this makes my road too windy, and I don't like that. So what I could do some editing in here to make my life a little bit better for those roads, for those truck drivers. So what I would do, I'll just perhaps ICS, and say from there to there, just do some smoothing there, create a little bit of a better path. Done. I just see the recalculation of that. It's taking longer because it's streaming with the topo. Yeah, there you go. It's a much better road. Looks much better as well. So that's pretty much the dynamic that you will follow when you're doing your pit design. I'll start with the easier ramps and going up, and obviously then you still need to do the full access on the bottom of the pit. Like if I had to introduce a third road here just to see how it would look like, maybe clockwise from a given starting point, let's say there. Should turn off the trim with the topo because all the time I'm looking for a solution on the topo, so just trim this thing off. There you go. Gets quite clumsy in here. So if I look at the blocks in here, or how the contours look like, so this guy should be connected perhaps. So maybe I'll connect this bottom here. So I'm talking about elevation 590. So if I go to, or perhaps let's go to 610. Yeah. So if I go to elevation 610, there you go, and then clip it. Yeah. So maybe I can just simply create some connection here. That side. And I can close it. Right, and this should be, there you go. So road 2 go indefinitely going up. So road 3. So eventually I would try, if I had more time, switch back this road 3 to come and summit somewhere in there and have access to road 2 and 3. So if I perhaps just take my road 3 and say end elevation, this one, and then to a switchback somewhere. Let's see if I can do switchback somewhere. There you go. Doesn't work much. I can remove the switchback and perhaps add a switchback a little bit earlier. Yeah, not there yet. Needs a little bit more, 5 or 10 minutes of work, and I'll be able to pull this ramp to the point that sits somewhere in there and connect me all the way through road 2. Look, I think in terms of the webinar, I think we my idea was really to give you guys an indication and an idea of what you can expect out of this tool and how to perhaps use it on your side. This is a beta version and it's going to be available for you guys very soon. And I'm very excited about getting you guys to start using it and start sharing your outputs and results and suggestions, right? I think this is the time for us to engage with you guys and get feedback. And if something needs to be changed and adapted, we're going to be happy to do so, and that's the right moment, right? That's it for my side. I really would like to thank you for joining us. Please, if you do have some questions and some suggestions, please send to our email address, which is on the sales@dataminesoftware.com, and we will address it one by one. And if you want to call our office, please do so. Let's engage, get together, and I hope to see you guys on the next webinar series, part 2. Okay, thank you very much, and have a good evening and a good day. Doesn't matter where you are. Just enjoy the rest of your day. Cheers. Bye-bye.